Hi, I'm Brandon Graisley. I'm a high school math teacher. We're going to review some of the things you should already know quite a bit about in geometry, angles. We measure angles in degrees. And so you'll see things like 30 degrees, the little circle symbol represents degrees, or 15 degrees, larger angles, 127 degrees, and you can even have very, very large angles like this. And we'll talk about what that means in a minute. So we have different types of angles, different ways of classifying them. If you have a fairly small angle like this one here, I'm going to use the letter theta to represent that. That's a Greek letter. We often use Greek letters in geometry. If theta is between, that is 0 degrees and 90 degrees, as it's greater than 0 degrees, 0 is less than theta, or theta is less than 90 degrees, then we call that an acute angle. And the word acute means sharp, so you can maybe remember that right there. It's kind of a sharp point on the end. And if theta is just a little bit larger, if it is exactly 90 degrees, then we put that symbol there to represent the 90-degree angle, and we call this a right angle. Again, I'm assuming that this is all stuff you already know, but we're going to keep going here. And one more that you probably already know is when we have an angle that's a little bit bigger than 90, but not too big. I'm going to use a different letter for this. How about gamma, another Greek letter? If 90 degrees is less than gamma, and gamma is less than 180 degrees, we call that an obtuse angle. Obtuse means blunt, so that's not so sharp right there. An obtuse angle. And there might be one more that you're familiar with. This one, called a straight angle. There's the corner of the angle here. I'm going to draw a little arrow to show where I mean. This angle here is exactly 180 degrees, and we call that a straight angle. Okay, now there are two more that you may not already know. What if the angle that I'm talking about, instead of being this obtuse angle in here, is actually the angle on the outside, like that. And maybe this angle is, well, we don't always use Greek letters, let's use x. That angle x is bigger than 180, but less than 360. Then we call that a reflex angle. And to just reference the last one, what if the angle I'm talking about, we start here and we terminate all the way around in a big loop? That angle there, 360 degrees, a full circle, and we call that, it can be called a turn. It's also called a full angle or a complete angle. Any of those are fine. We don't actually use that one too much, but and sometimes we just say that that's a full circle. Okay, so those are the terms. Again, you're probably most familiar with the ones at the top here: acute, right, obtuse, and maybe straight. And these last two, reflex, and then the full angle, are most likely new. Okay, so what are we going to do with this right now? Well, in lots of situations, we know some information, and we need to find some missing information. So here, for example, there is a right angle. And suppose that I know, let me just do this here, that inside of this right angle, it has been divided into two pieces. And this piece in here is 30 degrees. And I have some unknown angle right there. There's x. Well, I know that this whole thing is 90. This little slice here is 30. And this remainder here must be the rest that adds up to 90. That is 30 degrees plus x equals 90 degrees. So subtracting 30 from both sides, I get that x must be equal to 60 degrees. This actually has a name. These two angles together, since they add up to 90, are called complementary, meaning they complete that 90-degree angle. Complementary angles. There's two or more angles that add up to 90. So it can be 3 or 4 or 5 angles. As long as they add up to 90, they're called complementary angles. And this thing right here is an example of using the complementary angle theorem. That is, if angles add up to 90, you can just use this to find the missing one. Some people will write this, Complementary Angle Theorem, to say I knew this because I recognized that these were complementary angles. So for example, I might have another right angle, and perhaps it's divided up into 3 sections. And I know that this is 55 degrees, and this is 20 degrees, and this is some unknown value. We'll call it y. Then I know that y plus 55 degrees plus 20 degrees must equal 90 degrees. And you might write complementary angle theorem in brackets with that. And then you can solve that. Let's see. Y must equal 15 degrees. Okay, so that's the kind of thing that we use that for, is finding missing angles. Now, that's when we have a 90-degree angle, but lots of times we also have what's called a straight angle. Sorry, we've already talked about that. There's a straight angle, and we may know one part of that straight angle. There's 40 degrees right there, and then this other side here is missing this unknown value. Let's call it z. Then I know that z plus 40 degrees must equal 180 degrees, since it must add up to a straight angle. Z therefore is 140 degrees. Now this one is called the supplemental angle theorem, because whenever you have 2 or more angles that add up to 180, they are called supplementary. I think I said supplemental. Supplementary angle theorem. Okay, so very same idea as the complementary angles, except it happens to be the case where we get 180 degrees out of it. So nothing super shocking there, I hope. Now, let me show you another one. Here's a straight angle, and then there's another one right here. I've got 2 lines that are crossing, 2 straight lines, they cross, and let's say I know one of those angles, 70 degrees, but I don't know any of the others. Turns out we can figure out what each of them is. So take a look here. There's 70 degrees, but then also this angle A right in there. You see how those 2 together are make supplementary angles? Together those must be 180. So I know that 70 degrees plus A is equal to 180 degrees. That's the supplemental angle theorem. And I can solve that to find out that A must be 110 degrees. But then I can use the same logic to see that A plus B is 180, but A is 110. I know that now. Let me just write that in here. So I know that 110 plus B equals 180. Again, that's the supplementary angle theorem. B must be 70 degrees. And using the very same logic again, I can see that C must be 110 degrees. And this is the way this always works out. These 2 angles here are going to be the same as each other. And these 2 angles here are going to be the same as each other. So we call this we call these opposite angles. That's the way I learned them and think about them. They're opposite angles because they are sort of across from one another. They're also called vertical angles, and I honestly don't know why that's the case, because it kind of works in both directions. But anyway, maybe somebody knows that. They're called vertical angles. So whenever you have this situation, here or here, 2 lines crossing, these guys on opposite sides always have the same angle. Okay, so that's it for the basic angle part, and I think I'm going to stop there, and I'll come back with another video for the for polygons.